What is electro-pneumatic circuit? Electro-pneumatic term is defined from the words electro, which means electrical, and pneumatic, which means air pressure. The electro-pneumatic equipment and system is an integration of electrical and mechanical components with compressed air source. Electro-pneumatic is a pneumatic control system where air pressure and direction of valve are controlled by an electrical current. Pneumatic is a method to transfer energy from one point to another using actuators which are driven by fluids under pressure. Both pneumatic and electro-pneumatic controllers have a pneumatic power section. In an electro-pneumatic control, the signal control section is made up of electrical components such as electrical input buttons, proximity, switches, relays, or a programmable logic control (PLC). This is an example of electro-pneumatic circuit. There are a few advantages of electro-pneumatic circuit. The first is lesser wear of parts. It means lesser installation jobs. Next is less parts are used, so we can reduce the working space. And last, sensor and controllers such as PLC can be included in the system.
Now I'm going to explain about figure 4.1 sustain output. We was requested to construct the pneumatic and electro-pneumatic circuit. Figure 4.1 referred to circuit control for sustain output using push button. We used a single cylinder and 5 two-way valve. When the push button pressed, the air was pushed through 5-way two valve in single cylinder. Therefore, it known as normally closed. In second figure, circuit control for sustained output using detent switch. The output for push button and detent switch was different because these switches keep the switch position and the switch position remains unchanged until a new switch position is selected. They are designed to be as normally closed, normally open, or changeover switch. Figure 4.2 non-sustained type output requested to design a ladder to control electro-pneumatic circuit, which is PB1 to activate A plus and PB2 to activate A minus. When press PB1, Y2 is working on while Y1 is off. When press PB2, Y2 is working on while Y1 is off.
Now I will explain to you about figure 4.4. As you can see in the circuit, our cylinder is in a retract position. This is the initial position. Now I will press start PB button. The voltage flow will flow directly into start PB button, as now it became a closed contact. Next, it will go through a stop PB button. Stop PB button was originally a normally closed contact and now directly into K1 relay. Now all the mixed switch that labeled as K1 became a closed contact. This is because the K1 relay turned them on. K1 mixed switch will also giving pulse to Y1 solenoid valve, making the Y1 5 two-way valve will shift its position. Now the air volume will then flow into one-way flow control valve directly into the cylinder. making the cylinder extend. This position will keep on holding because we use the sustain system. The K1 mix switch is still in a close contact caused by the voltage flow directly into it and stop PB and K1 relay. To change this condition, stop PB button is pressed and K1 relay is no longer receive any current flow, and all the mix switch K1 also became open contact. Y1 solenoid received no pulse and it moved to its original position. As the solenoid valve returned back to its original position, the cylinder will also retract. Now I will explain to you about figure 4.5. Our initial position is still same as before. It is in retract position. Here you can see that our circuit already have a voltage flow through it, through the SA0. SA0 is a limit switch or a roller switch, and it flows into the K2 relay. We use initial position of cylinder in a retract position as an end limit for SA0 setting. So it will directly flow into K2. This K2 relay will then make the K2 mix switch in and close contact. However, there is no voltage flow through it because of K1 still in an open contact. Now we will press K1 start button. Now start PB button became a close contact and flow through stop PB button, which is originally a normally closed contact, and making K1 relay turn on. All mix switch K1 is also became a close contact, and this causes the Y1 solenoid valve to turn on. This Y1 then make the 5-way solenoid valve shift its position and make the airflow to flow through one-way control valve into the cylinder. The cylinder will then extend. Once the end side of cylinder no longer touch the limit switch of SA0, the SA0 in circuit will become an open contact, making the K2 relay also turn off, and all the K2 mix switch became an open contact again. Once the cylinder is fully extended, it will touch the SA1. SA1 is a capacitive proximity switch. This SA1 will then give impulse to K3 relay and making all the mix switch labeled as K3 became in close contact, and Y2 will then solenoid valve Y2 will then be turned on. The 5-way solenoid valve will then switch its position. This means that the solenoid valve is in its original position again and making the cylinder retract back.